Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to find the domain of a function both algebraically and graphically. How are we learning it? Through the finding the domain notes and the finding the domain assignment. When can we use this information? To understand boundaries to determine which possible solutions fall within the boundaries and which do not. How do you know you learned it? By getting a score of 4 on the finding the domain assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Finding the Domain notes, and then I'll give you time to complete the Finding the Domain assignment on Desmos. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the reasoning with features of function study guide and any incomplete assignments that you may have. Let's take a look now at the Finding the Domain notes. The notes begin with the learning goals and success criteria. First, what is domain? Domain is a set of input values for a function. Domains can be expressed in words, such as the domain is from negative infinity to positive infinity. It could be in set notation, where we actually include which values it can take on, or interval notation, which looks like this with the parentheses. Now, what is an asymptote and a hole? An asymptote is a line that the graph approaches but never crosses. So, an example of this would be 1 over x minus 1. And we can say that it has an asymptote at x equals 1. Because anytime the denominator equals 0, that's a spot where it would be undefined, because now we're dividing by 0. And remember from closure, if anytime we divide by 0, we have an undefined value. So it's undefined at this point, so we create an asymptote there. Now a hole is a point that is not on the graph, and because it can be factored out of both the top and bottom. So it's where the graph continues on and then stops for a second and then continues on after that. So an example of this would be x plus 1 over x plus 1 times x minus 1. And we'd say it has a hole at x equals negative 1, because this can be factored out of both the top and bottom. And then we would solve that for x, and we get x equals negative 1. So how does this look graphically? An asymptote looks like this. So we have our graph here, and it gets really close to negative 2, but it stops and doesn't actually touch it. So it just keeps going up and getting really high here, but it will never actually cross this line of negative 2. Same thing here. It gets really close here to negative 2, but never actually crosses it. Now a hole, an example of that would look like this. So we have our parabola here, and then just at this one spot, it's missing. So the graph continues and does cross, it just has a point there where it doesn't actually exist. So how does an asymptote or hole affect the domain? Well, we can see here that our graph goes to here, so it goes from negative infinity, but then when it gets to negative 2, it stops continuing. It stops and has an upper boundary of negative 2, and then it picks back up again. So here, we go from infinity, and when we work back this way, we go to negative 2. So it has a domain of negative infinity to negative 2, and a domain of negative 2 to positive infinity. So how do we find the domain of a continuous function, meaning that it doesn't have a hole or asymptote? So we're given 3x minus 2 over 5, and we want to know what the domain is. Well, all we're going to do is we're going to rewrite this, distribute the 5 to both of them. So it becomes 3 over 5x minus 2/5. We should notice that this is a linear function. So therefore, it's continuous, meaning it goes forever. There is no minimum or maximum because it's continuous, so therefore it goes from negative infinity to positive infinity. So if it's continuous, it goes from negative infinity to positive infinity. If it's not continuous, it's going to break off and stop at some point. Now here's a discontinuous function, 5 over 3x minus 2. Well, we should notice that there is an x value in the denominator, which means there's a value here we can plug in to make this whole thing become undefined. So we're going to solve for that. So we have 3x minus 2, so we'd add 2 to both sides, and then divide by 3, which gives us 2/3. So if we plug in 2/3 for x, we're going to end up with an undefined function here at that spot. So therefore, we know it's going to go from negative infinity to here, and then from there back to positive infinity. So we end up with negative infinity to 2/3 and 2/3 to positive infinity. Now let's look at how we can compare the graphs of similar functions. So we can look at the x values and state where the graphs overlap if they overlap. And look at the x values and state where the graphs do not overlap if they do not overlap.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google.
Let's take a look now at the Finding the Domain assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. Now for this one, the first question says, click on Graph It to graph the function below, then state the domain of the set. So we have 3p minus 2 over 5. So we click Graph It, and notice it graphs the equation here. Now, below, we're going to state the domain. Well, we can see that it goes from negative infinity to positive infinity. It never stops. So this is negative infinity to positive infinity. And to put infinity on there, all I did was type in the word infinity. I hit submit, and then go to the next one. Same thing here. Equation looks similar, but it's going to be different, so we hit graph it. Now here's what we have. We'll state the domain. So the domain goes from negative infinity to about a little over maybe 1/2. So we'll call that 1/2. So negative infinity to 1/2, and doesn't actually touch it. And then it picks up on the other side. So it goes from 1/2 to positive infinity. So those would be my domain. And you'll do that for each of these. And all the way until you get to the end. Once you get to the last one, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.